Okay, in 5.1, we classified polynomials. 5.2, we graphed them. Graphing them in a way is solving them, but of course by graphing. In 5.3, we look at how to solve polynomial equations by factoring and using algebra. Okay, what your steps are when you're solving polynomial equations, the first thing you want to do is write it in standard form and make sure it's set equal to 0. Do you guys remember what standard form is? It's when you put your exponents in decreasing order. So the exponents are in decreasing order, standard form. Okay, once you have written it in standard form, you've simplified it if it needs it, and set it equal to 0, then comes the second part, factoring. You may have to factor difference of squares, factor difference of cubes, sum of cubes, factor by grouping, and I'm going to go over all of those things with you before we actually solve. Are there people just, I guess people outside just hanging out in the hallway. Well, when y'all shut the door, please. Xander, how many people's out there? Oh, okay, I got you. Yeah. All right, once you factor it and set each factor equal to 0 to solve for your solutions, you may have imaginary and real roots or solutions. And remember, we talked about roots, zeros, solutions, x-intercepts, that all means the same thing. Okay, if a polynomial will not factor, then how you solve it is by graphing. And you can go to desmos.com on your phone, on your laptop, and you type in your equation. I'm going to show you how to do that. You can graph it, find where it crosses the x-axis. That's your solutions. So this is actually a way you can check your work after you do it algebraically too. Okay, before we solve, let's go over factoring. Now, in your 5.2 and your 5.3 in Math Excels, your directions are going to be slightly different. So in one case, they're going to ask you to factor the polynomial and just leave it in that form. The next problem may ask you to solve it. So you have to pay attention and note the difference. If you're factoring, that's all you're going to do. You're not going to set each factor equals 0, solve it. You're just simply going to factor it and leave it alone. All right, there's some special cases that we need to go over that we hadn't talked about in a long time. One of them is the sum or difference of cubes. If you have a calculator, you can get it out. If you need to borrow a calculator, you can come get one out of that box. Because I'm going to show you how to use your calculator to find cube roots. Okay, this is how you know if you have the sum or difference of cubes. This is what you're looking for. You're only going to have 2 terms. All of your exponents are divisible by 3, because remember, cubic relates to an exponent of 3. Exponents are divisible by 3. And all of your numbers or constants are perfect cubes. All of your numbers or constants are perfect cubes. Okay, now what's the tricky part is recalling what number is a perfect cube. And of course, you can use your calculator to get this as well. The very first one, of course, is 1, because 1 to the 3rd power is 1. What is 2 to the 3rd power? On that calculator, you're going to see this key. It's, let me show you up here. You'll have this hat key. So if you hit 2 and then find that hat key, and then that's your raise button. So 2 raise 3rd, hit equal, should give you 8. On the other hand, you can take the cube root of 8 to see if it is perfect. So you should get a whole number answer. And find this key on your calculator. It's got an X and then a square root. Do y'all see that anywhere on your calculator? X and then square root. So this allows you to change what root you're taking of a value. So you can take the 4th root of a number, square root, 5th root, 6th root, any root you want. If you want to take the cube root, you're going to type in 3 first, cube root, and then hit 8, hit equal, and it should give you 2. Tell me what the cube root of 125 is. 5. Okay, so now that we're listing perfect cubes, I have 1 cubed, 2 to the 3rd power is 8. What's 3 cubed or 3 to the 3rd power? 27. What about 4 to the 3rd? 5 to the 3rd. What about 6 to the 3rd? 216. Okay. 7 to the 3rd should be 343. Somebody double check me on that. And then 8 to the 3rd, 9 to the 3rd. I mean, of course, they keep going forever. Another common perfect cube you might see is 1000 or 10 to the 3rd. All right, so anyway, that's how you pick out if you have the sum or difference of cubes. You only have 2 terms, plus or minus in the middle, exponents divide by 3. All your numbers are perfect cubes. And this is you've got a formula. So let's say that you've got a to the 3rd minus b to the 3rd. You have the difference of cubes. This factors, you're going to take the cube root of both terms. That first sign is going to be the same. How you get what's in the second set of parentheses, you square this first term. This second sign is always different from that one. So second sign is always opposite. You take A and B, whatever term is here, whatever's in the A and B spot, you multiply them together to get the middle term. This last sign is always plus, and you square whatever's in B spot to get that. So square the last term to get the last term here. If you have the sum of two cubes, the formula is practically the same except for signs. Tell me what you will have in this first set of parentheses based on what you have above. Good, you'll have a plus b. And this second sign is always opposite. The last sign is always a plus sign. Same thing applies. You'll square whatever your first term is to get your first term here. You'll square the last term to get your last term here. And you'll take a and b, whatever those terms are, multiply them together to get the middle. Your signs are like predetermined in a sense. First sign is always the same as what's in your problem. Second sign is always opposite. Last sign is always plus. Okay, we're going to practice factoring cubes before we move on to grouping. The other types of factoring you should be more familiar with. Okay, notice that your directions just say factor the expression, and you're given this 1 plus 8m to the 6. Okay, how you can double check, you've got two terms. Are 1 and 8 perfect cubes? Yes. And if you did not know that, then all you have to do is type in cube root of whatever number you have and see if you get a whole number answer. So cube root of 8 is 2. And then the last thing, are your exponents, which is the only one of 6, is it divisible by 3? Yes. So we have the sum of two cubes. This first sign, remember, is always the same. What will the second sign be? Good. What about the last? And then to get the terms here, you take the cube root of 1, which is 1. And then you have to take the cube root of all of this. So the cube root of 8 is what? 2. And then to take the cube root of a variable and exponent, you just divide the exponent by 3. So that's going to be m to the what? M to the second. All right, how you get this first term is you square this, whatever's in the front here. So 1 squared, 1. How you get the last term is you have to square 2m squared. You're squaring all of that. So 2 squared is 4. M squared is what? What's m squared times m squared? There you go. Exponent to exponent multiply. And then to get the middle term, you take 1 and 2m squared. You multiply that. So that's, of course, going to give you just 2m squared. So I'm just going to write, I know I've done a lot of arrows, so I'll write again what the answer is. Okay, so your final answer is that. How do y'all feel about that? Do you have any questions? Okay, number 2, 3 into the 4th minus 24 NP cubed. In any problem that can factor, or that, well, possibly, see if there's something you can factor out to begin with. Do these terms have something in common? Good. They both have at least 3 in common. They both can be divided by 3, and they both have an m. So if you factor that out, what are you left with? M to the what? If you pull a 3m out, you're left with m to the 3rd, right? I think I heard somebody say it. And then if you factor out 3, you're left with 8. We pulled that m out, so we're left with p to the 3rd. When you're factoring, always make sure that nothing will keep going. And if you look inside parentheses, this is the difference of what? Good. It's the difference of cubes. All of your exponents, which are both 3, will divide by 3. 8 is a perfect cube. So what you do with 3m, this is what a lot of students miss. You have to keep just bringing 3m down every line that you go out front. You can't forget it. So then let's factor this part. This sign should be what? Good. The first sign's always the same. Second sign's different. And the last sign is a plus sign. What is the cube root of m to the 3rd? M. Cube root of 8 is 2. Cube root of p to the 3rd is p. And then you square what's in the front. So if you square m squared. Squared 2p. So that becomes 4p squared. And then multiply m and 2p. So 2pm or 2mp doesn't matter. Okay, do y'all have any questions about that? All right, let's look at a factor by group then. Okay, how you know that you can use factoring by grouping is if you have 4 terms. Cannot be 5, cannot be 3. It has to be exactly 4 terms. And you want to pair 2 terms together to have something in common. Pair 2 terms together that have something in common. That have a greatest common factor. And then the other 2 terms, when you pair those together, they should also have something you can factor out. Okay, so in number 3, You have 4 terms. They all don't have something you could factor out to begin with, and there's nothing to combine. So the next step, what you want to look for, pair 2 things together that have something in common. And what I like to do that keeps it simple, if I can pair the first 2 things together and then pair the last 2 terms together, then I'll do that. And if you'll notice, the first 2 terms do have something you can factor out, which is what? Good. They both have x squared. What are you left with? With x. There you go. Now, in the last set, they both have what? What do they have in common? Good. They have a 5, and I would definitely factor out a -5. And somebody asked me earlier, they said, how do you know when you're supposed to factor out a negative? Notice if I ignore those first 2 terms, I've got -5x minus 10. This is your leading term in a sense for this half. So when I have a lot of negative signs like that in my problem, I'm usually going to factor out a negative. So that'll leave you with a positive x plus 2. Now, another reason I factored out a -5, it left me with the same thing in parentheses as I have here, and that's what you want. If you don't end up with that, then it won't factor and you have to solve it by graphing. But we'll talk about that later. All right, now from this point, you've got this is 1 term and you have this is 1 term. What do they both have in common that you can factor out? Good. So you bring the x plus 2 they have in common down in 1 parenthesis, and then you write what's left outside, x squared minus 5, in your other set of parentheses. So your goal when you're factoring by grouping, what's inside parentheses should be the same. You write that in 1 parenthesis set, what's outside in the other. You guys have y'all done that before? I was gonna say, like my last class was like, okay, yeah, we've done this before. I know we've talked about it a long time ago, but it's been a long time. It's like way back before Thanksgiving break. Okay, now that we looked at all that, all right, now let's solve. So if they just ask you to factor, like number 2, if they just said factor it, that's what you're typing in. And like in number 3, factor it, you're stopping here, typing it in. Okay, now to actually solve some, your directions may say to solve the polynomial equation, or it may ask you what are the real. Yeah, go ahead. What are the real and imaginary solutions or roots? So that's how you know you're going to go a step further and actually solve. And I'm just going to number this 1 because we're in solving category. We have 2x cubed minus 5x squared equals 3x. What is your degree or highest exponent? What's your highest exponent here in this problem? Good. Your degree equals the number of solutions you should have. So for this polynomial, when we solve it, we should have 3 answers. Going back to your steps that you wrote down at the first of the lesson, you have to set it equal to 0. So I'm going to subtract 3x, set the right side equal to 0. Okay, your next step is to factor it, if it will. Is there something I can factor out of all 3 terms? Good. You can factor out an x. So that'll leave you with 2x squared minus 5x minus 3. Okay, you factor it and set it equal to 0. We already can clearly see one answer. X is a factor. So x equals 0. That's one of your answers. Your other answer is going to come from setting 2x squared minus 5x minus 3 equal to 0. Okay, how do you factor this? Because it can keep going. Do y'all remember how to factor a quadratic when it had a number in front of x squared? Good. You take 2 and multiply it to 3. So this turns into x squared minus 5x minus 6. Then you factor this. It's a trinomial, so remember it factors like this. What are 2 numbers that multiply to 6 but subtract to 1? Good. 6 and 1. And 6 has to go with a minus sign and 1 with a positive. Does everybody understand where these signs come from? Y'all know that if that last sign is a minus sign, that they're different signs? Okay. And then you think about -6 plus 1, that has to give you -5 in the middle. And -6 times 1 has to give you that. All right, anyway, now that you have that, we have to now divide by 2. So that number you took and multiplied, you have to remember and divide to make it equal out. Simplify any part that will. You can't, one half is simplified, so remember you move 2 up in front of x. And then 6 can be divided by 2, so that simplifies to 3. Okay, so we've factored this. Now the last step is actually solving it. You take each factor, set it equal to 0 to solve it. And of course, most of that you can do in your head. Like you can think about if you subtract 1, divide by 2, like what is x? X should be -1/2 or -0.5. What about for this set? X is what? 3. And notice we ended up with 3 answers: 0, -1/2, and 3. These problems are a lot of work, but, and you have to remember factoring and stuff too. All right, for this number 2, what is your degree? What's your highest exponent? 4. So you should have 4 solutions. Make sure it's set equal to 0. The easiest thing to do, bring 6x to the third to the left side. Okay, what do all 3 of them have in common you can factor out? What number can they all be divided by? Good. They can all be divided by 3. And then what else did you say? And then, good, they all have an x, and you take the one with the lowest exponent. So they all have an x squared. All right, let's see what we're left with from that point. When you factor out a 3 and an x squared, you're left with what here? X to the second. And then all you do is divide. Good, you're left with 2. And then x to the what? Good, x to the first. And then at the end, we have plus 4. And then I don't have anything. So I got myself right to that room. Okay, if they ask you to factor it and that's it, then you would type in that answer. And the reason is, you're going to see when we actually solve it, this part will not keep factoring. It looks like it will, but it won't. Are there 2 numbers that multiply to 4 that have a sum of 2? No. So that's why this won't keep factoring. So if they ask you to factor it, you type in just that part and be done. But they ask you to solve it or find the solutions. So now we've got this factor, 3x squared equals 0. And we have this factor, x squared minus 2x plus 4 equals 0. Okay, if we solve this for x, divide by 3, you get x squared equals 0. So x is what? Good. X is 0. So there's one of our answers. Now, I'm going to stretch your brain a little bit. Going back to section 5.2, when we graphed and we talked about multiplicity, if you were to write out x squared, how many times would you see it? If you wrote out x squared, you would have how many x's? 2. So this answer has a multiplicity of 2. So it counts for 2 answers. And you're going to see why when we solve this side. I know, like, some of you are probably like, huh, what? Like, what did you just say? But hang with me. All right, how do we solve a quadratic that won't factor? Use this lovely, awesome formula. So if it won't factor and you're asked to solve, you have to use the quadratic formula. All right, what is A? What is the number in front of x squared? Good. What is B? B is, there you go. B is -2 and C is +4. So let's go through and plug in. B is -2, but when you plug in here, it becomes +2. Square 2, so I'll give you 4 here, -4 times A, which is 1, times C, which is 4, and that's all divided by 2 times A, which is 1, so you get 2. All right, when you type this in your calculator, you can just type in 4 minus 4 times 1 times 4 and hit equal. You're going to get -12. All right, in section 4.8, which we did right around Thanksgiving, we learned about imaginary numbers and took square roots of negative values. Do you guys remember, what do we bring the negative sign out as? Do y'all remember that? The negative sign comes out as some letter. Good. So I bring the negative sign out as I for an imaginary number. And then we still have √12. And I'm showing you step by step in this problem, but you can definitely skip steps if you're familiar, if you're more familiar with it. Okay, from this point, we have to double check this radical, see if it will break down. Is there a perfect square that divides 12? 4. So 12 breaks down into 4 times 3. So you're gonna, this will turn into, you take the square root of 4, but you leave √3. So that turns into 2 √3. 2 comes out front with I, you're left with √3. And that's all over 2. Last thing you have to double check, can the number on bottom divide into the numbers on top? Or will the numbers that are all outside the radical reduce? 2, 2, and 2 have a common factor of what? 2. So if I divide everything by 2, or the way you can think about it is the numerators share this denominator. So divide 2 by 2, get 1. Bring down positive negative, divide 2i by 2, and you're going to get 1i, and then leave √3. So that's your final answer. 1 plus or minus I √3. Now, what Math Excel is probably going to make you do, you don't have to write this down. They're probably going to make you split them up and say 1 plus I √3, comma 1 minus I √3. Okay, last problem. Okay, what do you have to do first? Good. So let's move 16 to the left side. All right, now for this problem, this is a trinomial. They don't have anything you can factor out in common, but it will factor very similar to a trinomial. Instead of this being x squared and us having x and x, you've got x to the fourth, so you're going to split that up as x squared. Your sign at the end is plus, so both of them come from the middle. What are two numbers that multiply to 16 that add up to 17? Good, 1 and 16. Always check and make sure it won't keep factoring, and both of these will. This will keep factoring as well as this. Can you mind tell me what's special about x squared minus 1 and x squared minus 16? Good, that's difference of squares. So x squared minus 1 will factor in x plus 1, x minus 1. Difference of squares will always have different signs. So one's x plus, one's x minus, and then you take the square root of that number. So square root of 16 is 4. Okay, now you can just use mental math and go through each factor. You've got this factor, this one, and this one, and this one. So you should have 4 answers. Go through each and use mental math to tell me what value of x would make this 0. Like what would make this 0? -1. So x equals -1. What about here? What would make this 0? 1. And then what plus 4 would give you 0? -4 and then +4. So if they ask you to factor it, you would be done at this line. If they ask you to solve it, you type in those values. All right, work on your 5.3. If you didn't get through with your 5.2 stuff, I extended that until Sunday night, this upcoming Sunday. And that's also when 5.3 is due as well. Yes, go ahead.